Hello students, in this video we'll see a problem involving a functional equation. Let's suppose that f maps R to R is continuous at a point, is continuous at x equals 0, and satisfies the following functional equation if f satisfies the functional equation that f of x minus f of x over 2 equals 0 for all x. Let's put this into a plus, actually, it won't work otherwise. For all x in R, then f of x is identically equal to 0. Okay? So in other words, if this functional relationship is true, if f of x plus f of x over 2 is equal to 0, and f is continuous at the origin, then the function is identically 0 everywhere. Let's see how this works. So the first thing to observe is that I can plug in 0 to this equation, and that would say that f of 0 plus f of 0 is equal to 0. So 2f of 0 is equal to 0, which forces f of 0 to be equal to 0. So that's the first thing. That's the important fact over here, that the value at the origin is equal to 0. Now what can I do? Now I can take our recursion relationship and write it in the following way. I can write f of x is negative f of x over 2. But now I can use this recursion over again. I can iterate this and say this is what? This is negative f of x over 2, which is positive f of x over 4. I can do the same thing again and say this is negative f of x over 8. Okay? And so what's this going to be? So this, with 3 times I get a negative, so I claim if we do this n times, what will happen? If we do this n times, I'm going to have a negative 1 to the n. The parity should be correct. F of x over 2 to the power n. Okay? And so now what's happening over here? So I have a bounded sequence over here. And what can I say? So now what happens when I let n go to infinity in this formula over here is n goes to infinity, this oscillates between positive f, this will go to what? So this term over here is going to go to f of 0, and this is going to oscillate between negative 1 and 1, right? So as n gets large, by the continuity, the limit as x goes to 0 of f of, as n goes to, as n, let's do this, let's do the limit as n goes to infinity. So let's do that first. So the limit as n goes to infinity of f of x over 2 to the n is equal to f of 0, since f is continuous at 0. Okay? So what I have now is I have that f of x is two sequences over here. This is a sequence an, and this is a sequence bn, right? And that's true for all n. And this an sequence is bounded. So here an, negative 1 to the n, is a bounded sequence. And f of x over 2 to the power n is a sequence that converges to f of 0, but we know that f of 0 is equal to 0. So I have a bounded sequence times a sequence going to 0. We know a bounded sequence times a sequence going to 0 is 0. So the conclusion is that the limit as n goes to infinity of my bounded sequence times my sequence going to 0 is equal to, well, this is equal to, it's true for all values of x. On one hand, this is f of x, because this is valid for all n. On the other hand, this limit is equal to 0. So we've just shown that f of x is identically equal to 0 for any value of x. Thank you very much.